That's great. So, welcome everybody. Good evening, good afternoon, everyone. We are very glad to have you here today for this webinar on GIS tools and their importance in supporting sustainable natural resource management. As we face urgent global challenges like climate change, deforestation, water scarcity, and biodiversity loss, the role of geospatial technologies has never been more critical. GIS tools provide us with powerful means to visualize, monitor, and understand complex environmental systems, enabling data-driven decision-making and more effective targeted interventions. From mapping land use change to tracking water quality or supporting community-based solutions, GIS is helping bridge science, policy, and practice. These tools hold tremendous potential to support the implementation of essential measures aligned with global sustainability commitments, including the 2030 Agenda for Sustainable Development, the coming Montreal Global Biodiversity Frameworks, and climate adaptation efforts, such as the Paris Agreement. Today, we will explore how GIS, or Geographic Information System, is making a real difference in the field through concrete examples and the inspiring work of our guest speakers. This webinar has been made possible through the general support of the German Academic Exchange Service, or in short, DAD, and the German Federal Ministry for Economic Cooperation and Development, the BMZ. It is part of this webinar is part of our ongoing online course on monitoring and reporting, Introduction to Geographic Methods using open source softwares. Such trainings are offered every year, and if you are interested in applying for one of them, you are more than welcome to follow us on our social media and receive our latest updates. Our team will share our social medias links on the chat. And thanks again for joining us, and let's get started. So, the organizers, this webinar is jointly organized by these organizations. The first one, Action Network Worldwide, is an umbrella organization that both Weltweit and BluoVerda are part of. The Action Network is an alliance among different nonprofits who collaborate with the common goal of supporting initiatives on the Global South in favor of nature and local communities. It is also a place where you can meet other fellow professionals and colleagues, as well get to know about possible fundings and opportunities for course and projects. So in the link shared is also a link to join the Action Network. This second organization, Weltweit, was founded in 2014 by a diverse international group, many of whom lived in Germany and have backgrounds in international cooperation. Their focus is on connecting technical, financial, and logistical resource from industrialized countries, such as Germany, to local projects in more vulnerable regions. They believe communities understand their own challenge best, and their role is to support them instead of imposing solutions. They offer targeted solutions to students, alumni, and practitioners through specialized training and coaching, equipping them with the tools needed for both the theoretical and practical aspects of their projects. This way, they are better prepared to implement meaningful change on their own countries. And now the second organization, BluoVerda. BluoVerda is Deutschland is a diaspora nonprofit organization that works in the field of education for sustainable development, development cooperation, nature conservation, and sustainable management of natural resources. Together with partners in Europe and overseas, BluoVerda designs, implements, and support innovative and inclusive approaches to develop sustainable pathways based on empathy and respect for people and nature. BluoVerda actively uses education for sustainable development as its main approach to working in informal and non-formal education in Europe, such as this course, for example. We are around 25 members, most of us coming from Latin America. And now let's meet the experts and the speakers. My name is Bárbara Carneiro. I am the moderator for today, and I'm a member of BluoVerda and the Action Network Worldwide. And we have the great pleasure to have here three speakers today. And Audrey Kans Dosu Kojia, I'm very sorry if I pronounced your name wrong. He is a water and environmental scientist with expertise in integrated management of water, land, and climate systems. He holds a Master's of Engineering in Water, Sanitation, and Hydro-Agricultural Development, a Master of Science in Eco-Hydrology, and a Bachelor of Science in Environmental Engineering. His works focus on the use of geospatial tools for environmental monitoring, decision support, and sustainable resource management. Currently, he is a project and research assistant at WASCAL, the West African Science Service Center on Climate Change and Adapted Land Use. Other supports international projects advancing land, agriculture, and water governance. Thank you for being here today, Audrey. The second speaker will be Ricardo Paris. Ricardo is a urban planner and a PhD candidate at the Ruhr University Bochum in Germany, where he researches international development with a focus on territorial conflicts in Mozambique. He holds a joint master degree in spatial planning from the TU Dortmund University here in Germany and Kwame Nkrumah, University in Ghana, where his fieldwork examined land rights and rural development. With over a decade of applied experience, Ricardo has worked on food security, urbanization, and resilience projects for the United Nations in Brazil and Bolivia, and led participatory development plans across Brazilian cities and Ghana. His expertise breeds grassroots realities and policy frameworks, combining geospatial analysis, ethnographic methods, and participatory planning. Thank you also for being here today. Our third speaker is Luisa Sterponi, and she brings nearly 2 decades of experience in remote sensing applied to territorial analysis and the integration of GIS. She holds a bachelor degree of biological science from the University of Rome and a master's degree in space system on Earth observation from the University of Lecce in Italy. Luisa has extensive experience working with the Peruvian public sector, addressing complex challenges such as detecting deforestation, analyzing land use change, monitoring illicit crops, and integrating optical and radar data. She works as the coordinator of the United Nations Office on Drugs and Crime, Illicit Crop Monitoring System. Thank you very much for being here today as well. So just a short agenda. Audrey will present about the title of his presentation is Operational Monitoring on Reservoirs in Burkina Faso using Satellite Remote Sensing. He will present for 15 minutes, and then we will go directly through Ricardo's presentation on Digital Beehive, Community Development through Spatial Science and Sustainable Production. Following the presentation from Luisa, integrating multi-source data for geospatial analysis on drug and crime using QGIS. Case study, environmental crimes and coca cultivation in Ucayali, Peru. After the presentations of the three speakers, we will have a space for questions and answers, and with a closing remarks. Thank you very much. So yes, I will now stop my presentation and give the floor to Audrey, please. Welcome.
Okay. Thank you, Barbara. So let me share my screen. Can you please see my screen?
Yes, we can see.
Okay.
Yes.
Okay, so I've already been presented, so I will just start with my presentation. So the work I will be presenting is entitled Operational Monitoring of Reservoirs in Burkina Faso using satellite remote sensing. And it's part of the DIWASA. DIWASA is Digital Innovation for Water Secure Africa projects implemented by the International Water Management Institute. And the work has been done in collaboration with the International Institute for Water and Environmental Engineering in Burkina Faso and the General Directorate for Water Resources of Burkina Faso. I'm also working at WASCAL in Burkina Faso. So my presentation will be very academic. So I will start with an introduction, and we will have the material and methods, followed by the results and discussion, and we end with the conclusion and perspectives. So we all know that water is life, and about 3% of Earth water represent fresh water. And this fresh water is not equally distributed on the Earth. And we have in some areas less renewable fresh water. And in some countries like Burkina Faso that you have in red, the total renewable fresh water is a bit low. So over the past year, let's say before in the past, it was very difficult for population to have access to water, especially in rural areas. And it was very difficult for population to have access to water for irrigation, for their livestock, or even for their domestic purposes. So the government had decided to build dams. So we have about 1,800 reservoirs in the country, and most of them are small. But only 24 of them are monitored in the country by the Directorate General of Water Resources. But currently in the country, we have some issues. We have ongoing issues related to insecurity. We have limited funding for in situ data collection, and we have no means of verifying the quality of the data that is collected by the agents on the field. And they collect mainly water level data on the reservoirs. But nowadays, satellite imagery are used to gather information on the Earth, and especially satellite data are used to collect data on, let's say, forests, water resources, uh, built-up area, and other environmental uh, uh, um, system on the Earth. So this study aims to explore the integration of satellite remote sensing observation with field data to estimate reservoirs volume in Burkina Faso. So for that, we first drafted a review on remote sensing approaches for estimating physical characteristic of reservoirs. And in terms of characteristics, we have surface area, we have water level, and we also have volumes. But I will not present the review here. I will present our case study. So the specific objective are to analyze the spectral separability of ground truth control points that we use for mapping reservoirs, assess the accuracy of mapping the surface area of reservoirs using series of Sentinel-1 and Sentinel-2 imageries and machine learning. And finally, to estimate reservoirs or reservoir volumes at the spatial temporal scale using remote sensing and in situ observation. So I will briefly present the study area. So the study area is Burkina Faso, and we have a dry tropical climate with the Sahelian, North Sudanian, and South Sudanian zones in the country. We have two seasons, the rainy season from May to mid-October and the dry season from mid-October to April. And we focus our study on 20 reservoirs out of the 24 monitored, because for the 4 remaining reservoirs, we do not have much more information to use for our study. So the maximum area of the study reservoirs are between 123,000 hectares, and the maximum depth is between 2 and 20 meters. So this reservoir are used for domestic use, irrigation, livestock watering, but also for hydro production. So I will present the satellite imageries that we use. So as I was saying, we use Sentinel-1 that provide radar imagery. So the release time is 6 days, and we collected about 4,000 images for all the reservoirs. And we also use Sentinel-2 imagery with a release time of 2 to 5 days. And we also gather about 1,700 images. And the period is between 2014 for Sentinel-1 and 2015 for Sentinel-2, up to 2022, according to the data the in situ data that we have. So we also use ground truth data and observed data. For the observed data, we gather data from the General Directorate of Water Resources. We gather water level data and reservoir coordinates. We also use high resolution imageries from Google Earth Pro. So about the methodology that we use, we have mainly five main process. And the first one is image processing. So we use the Sentinel-2 and Sentinel-1 images for our study. So for the Sentinel-2 imagery, we try to filter out clouds because the optical images are affected by clouds. And we added some spectral indices. For the Sentinel-1 imagery, we filtered speckles and we masked images borders. And then we have tried to select ground control points that we feed our random forest classifier that we use for the classification. We try to analyze the spectral separability. So for the image classification, we use random forest, as I was saying, and after classifying, we try to determine the accuracy, but also we validated our classification with high resolution images. And then we were able to calculate the surface area of the reservoirs. And for that, we try to sum up all the surface area that we estimated for all the days between the period that we considered. And then we finally estimated the volume and develop a kind of relationship between surface area, water level, and volume. So for the result, I will start with the spectral separability of training data. As you can see, for the small reservoirs as the one of Luda that I'm presenting here, it was very difficult to, let's say it was very, we tried to select the points, the ground control point very carefully because the reservoirs dry up in the dry season. So you can see at your right that where we have selected the points. And for some big reservoirs like the one of Ziga, for instance, it was easier. And finally, we have tried to see if all the classes we have selected were very different. We could differentiate them in terms of their reflectance. And that's what you are seeing on this slide. And we can see that the other classes are well separated with the water classes. Then we were able to classify the images using Google Earth engine. And it helped us to have a very good classification for both Sentinel-1 and Sentinel-2 images. For Sentinel-1, for the small reservoirs that I'm presenting on this slide, you can see that we have the accuracy metrics, such as overall accuracy and the others, kappa, down to about 76%. But for Sentinel-2, we have higher accuracy, more than 90% for the accuracy. And you can see that for the validation, we have tried to compare with manual digitization. Manual digitization is what you have in red, and the blue, what we have in blue is the classification with satellite imagery. You can see that for Sentinel-1 at your left and Sentinel-2 at your right, is the classification is at least a bit good. But if you check with statistic, what you can see is that for Sentinel-1 imagery, we have about 0.2 for the coefficient of determination. And for Sentinel-2, we have 0.96 for the coefficient of determination. That means that Sentinel-2 better classify the reservoirs compared to Sentinel-1. And you can see that we have various different classification for both of them. And for the big reservoirs, like the one of Kompienga, for instance, you can see that we just have about between 35 to 43% of reduction in surface area between the, let's say, the rainy season to the dry season. But for a small reservoir like the one of Luda, we have much more. We have more than 90% of reduction in surface area. So we have tried to have determined the relationship between surface area, water level, and volume, and that's what we I'm presenting here. And you can see that for the Bagre Dam, for instance, that is a very big dam, one of the biggest of the country. We have very good accuracy, correlation between surface area, water level, and volume. And even for the small reservoir, like the one of Tusiana, that is about 150 hectares, we also have a very good correlation between the surface area estimated, the water level, and also the volume. But for other reservoirs like the one of Ouagadougou is not the case, because you can see that we have urbanization, we also have aquatic plants and all these things that leads to a very bad classification, like what you can see here with a coefficient of determination of about 0.45. So we have tried to, for all the 20 reservoirs, we have tried to identify the reservoirs for which we have a very good correlation that could be monitored easily by the managers of those reservoirs. And we have the equation they could be using to monitor their reservoirs. And we have trained them so that they could be able to determine the water level or the volume using the estimated surface area. So they have this equation that help them. So in conclusion, I will say that our methodology was able to give a very good accuracy using satellite imagery, especially Sentinel-2, gave the best classification. And the surface area and volume relationship was good for 15 out of the 20 reservoirs studied. We have aquatic plant and other constraints, but for the 15, the relationship was very good. And our methodology is usable by the officers in charge of reservoirs monitoring in the country. And the study also could be applied in other countries where they have people are facing issues with reservoirs monitoring. So out of our work, we have published one paper estimating water levels in a reservoir using Sentinel-2. So we focus the published paper on Sentinel-2 imagery. But we also have a review that is in progress on remote sensing tools for estimating reservoir physical characteristic estimation. So for the future study, we are thinking of detecting aquatic plants on reservoirs. We are also thinking of physical monitoring for non-monitor reservoirs. And we also want to link climate data and physical characteristics of reservoirs. Thank you for your kind attention.
Thank you very much, Audrey, for this presentation, and indeed very scientific, but I believe this is it's great for today because we have three different areas. And I forgot to mention that Audrey is a alumni from this course of the monitoring and reporting using open source tools. So we are very, very happy to have you here. We have some questions on the chat, but we will ask when we finish all the presentations. Thank you very much again. And
thank you.
yes, thank you. I will invite now Ricardo to present his presentation.
Yeah. Hello, everyone. Thanks a lot for inviting me. I'm sharing now my screen. And yeah, so thanks a lot for this opportunity, and it will be indeed quite a different approach from the first one, but I think it's really nice to have different perspectives. What I'm going to present is actually it's an idea. It's not even a prototype, but is an idea that I've been working with a group that's currently on hold, but we've working with this idea, and we approached several of these startup sponsors and this kind of pitch uh, meetings for startups. So the presentation will be kind of based on this on this general idea of what we have, and then I hope it to be clear at the end. So the project is called Digital Beehive Honey for Development. And how does the project started? I'm from Brazil, and so this is Brazil. And I was working, teaching, actually giving classes in a university in the northwest part of Brazil, which is kind of very poor, and but at the same time it has a very interesting geographical um, landscape. If you can see, there's this bright, this green. I don't know if you can see my mouse.
Yes.
Yes. Okay. Okay. So there's this green area nearby the ocean, but inside it's very dry. But you can also see some patches of green, which are mountains. It's kind of one of the best environments for. Sorry, no, it's not coming. What's one of the best environments for honey production. So this is somehow how does the landscape see. So it's very dry and flat with some mountains. And as I said, it's really tough for agriculture, but at the same time for honey production is one of the best in the world. And as I was teaching there, uh, some of my students were also or came from farming families. So I started to think with them some possible solutions, or yeah, to address these pressing issues for smallholder farmers. I put here in Brazil, but for sure these are general. It can be shared with almost every other region in the world, at least in the global south. So it is regarding aging population, the lack of difficulty of using technology, um, the difficult to access financial schemes for agriculture production, lack or poor social cohesion, confronting land uses, especially regarding big or middle scale farmers and small scale farmers. I'm going to get to that. Land degradation, access to water, access to land. So things that we know or we share the same problems. And basically, some of them are strictly social, and some of them are spatial. And more interesting than analyzing this is to understand how these points or these two broader areas integrate or overlapping. And here in these examples that I brought, the idea of confronting land uses is really key. And it was also something that was the starting point of this project. So the project was thought like this, like based on all these problems that I listed before, we started to think what would be if smallholder farmers would have a secondary or reliable or more reliable source of income if there was access to technology that monitors local environment, if we could build a strong connection to the land and to the community, and to build a partnership with an animal that's responsible for crop pollination. So, of course, we're tending to the idea of beekeeping, but this is how how we thought that all of these issues would be connected in somehow addressing the problems or the issues that I mentioned before. So the idea with this project is to build an online platform for territorial planning and beekeeping, but in fact, it's territorial planning for beekeeping. Like it works in both ways, which will support alternative sources of income, prediction of harvesting, community integration, and land use management. Yeah, I can enter a little bit specifically on this, but I think with the example that I show, we will be clear. But to prepare a project like this, the first thing that we as a group, and especially with the colleagues from Brazil, we started to think what are the information that is needed for this territorial management. What would be the production factors of beekeeping that would somehow integrate with landscape management and so on. Yeah? So first is the biome or the ecoregion. As I showed before, we were talking there in that context in Brazil in a kind of a savanna, a specific art of savanna. And to know this, to be important to know the possibility of production, how much the bees will produce or the access to other environmental needs. Also important to us is to differentiate or to understand different land use types. If you're talking about urban vegetation, crops, industry, and how are they all integrated or how they are all spread in the landscape. And within these land types, which type of vegetation are you talking about? If you're talking about beekeeping, it's really important to understand from what will they be feeding? If cash crops, if fruits, fruit trees, or natural environment, or whatever. Why? Because of the use of pesticides. As we know, bees are very sensible animal, and for in several regions of the world, they're dying in large amounts, especially because of this of the proximity and the use of pesticides. So it's crucial to understand this point. Water bodies, extremely important for the bees. Property ownership, because, and this is kind of really interesting because bees, they don't respect borders. And this is what brought us the whole idea that I brought in the beginning regarding this community cohesion. As bees don't respect borders, somehow community needs to integrate themselves to avoid conflicts. One of the possible conflicts is overlapping of the hives. And also important to know the type of bee, because this would mean, for example, the area that the bees are flying to get their food, and the type of interaction between different types of bees are really important, because there are some bees, of course, that are more dominant and they can even lead others, normally the native ones, into extinction. So it's really important to know the type of bees that we are working with. And now, as spatial planners or geographers or whatever we are, I realized that oh, sorry, that everything that we are talking about, all of this information that was kind of key to understand the process of beekeeping, uh, it can be spatialized. So we can put all of this information in the map. And then I thought, okay, now we can really contribute something with this community or with this group of people. So this is the example, just like a just a illustrative example, and then I'll show you later our platform, how is it working somehow. But as an example of how it works, based on all this all this data, this spatial data, the producer will select the place that he or she put the beehive or wants to put, and from that, sorry that I need to, and from that we'll extract some open spatial data. So the location of the hive, this will be given by the user, then the land use and land cover of the area. In black, the lines that you see are the property borders, and this, luckily, in Brazil, we have a kind of a national cadastre of rural properties, although it's not really, as you can see, there are several overlapping areas. It's not really precise, but at least we can understand somehow this issue, or who we should talk to, and so on. And the radius of flight of the bee, as I said, depending on the species. With this data, it's kind of easy. I'm sure that all of you have learned already during this course. We shift into a binary factor of what is bee pasture and what's not bee pasture. And from that, we can do several estimates. And this is somehow the final report, so to say. So we have this estimate of or the calculation of land covers that we are dealing. And from this land cover, how much is bee pasture, how much is not bee pasture. The biome factor, as I said, this savanna, it's already well known in literature which type of biome has a specific factor of production. So, as I said, this type of savanna is one of the biggest or the best in the world. Is 4 times factor. So this is just a calculation modus. And from that, we can establish the potential number of hives that this area would comprise, the number of properties affected, the overlapping factor, because the idea, this we're doing just with one, but the idea is as the users start to put their points, we need to calculate the overlap factor, and this will also, at the end, impact the expected production that is the last box here. So this was the first idea that we came about and discussed, and with this we organized this. Sorry, let me close this. So this platform is kind of a website that we always try to show to sell our idea somehow. Yeah, the idea is to have something to be shared. So we need to sell the idea if someone wants to sponsor or help or develop it further. So this is our website. So the challenge that we're talking is to deal with economic problems. So low rentability, inadequate incentives for innovation, lack of access to technology, absence of social cohesion in the social part, the out-migration of younger farmers. So we are sure that with increasing technology and increasing hopes, expectation of profits, it will be easier to hold these younger farmers in their fields. And environmental aspect, that's clear how important bees are for against land degradation, pollination, diversity of production and of fauna, right? So imagine if the smallholder farmer has a secondary and reliable source of income. Imagine if the smallholder farmer have a strong connection with land and community. And imagine if the smallholder farmer have increased pollination and biodiversity. So with this, we go to our solution. I won't talk too much about this. These are actually some of the things that I've spoken already. And we prepared a demo and using Google Earth Engine, like it's an open source, and not open source, but it's an open user app that would work. So theoretically, as I said before, so the user would locate the points that the beehives would be implemented, and automatically, and based on this algorithm that's already developed, it would work all around the world. Of course, some specificities regarding the access to the data of land use should be fought, of course, but theoretically, by feeding correctly, it would work everywhere. And the farmers or the community will have access to directly or instant result of land cover, of the amount of bee pasture, and at the end, this final data. Of course, as I said, this is the first idea that we are trying out, but a lot can be improved. A lot of new data can be added, and yeah, so that's the whole idea of the project. That, as I said, is still open to collaboration and to further development. So thank you very much. I think it was faster than they expected.
Wow, thank you very much, Ricardo. Such an interesting project. I hope it will be developed and you find the necessary partners and fundings for that. And as a Brazilian, I am also very happy to see a project happening there.
Cool.
Thank you very much. Okay, so we have also some questions for you, but we will later address it. And now I invite Luisa Sterponi.
Okay, hi everybody. Thank you very much for the invitation. And let me share the screen. Okay. Can you see the screen?
Yes.
Okay, great. So, hi everybody. I'm very happy to be here today and to talk about QGIS, because along these 20 years of experiences with geospatial tools and application, I fall in love with QGIS, let's say, especially when I moved to Peru, where I start to work with the public institutions that have not resources to buy licenses. And so I was exploring every year more tools, more capabilities of QGIS, especially one year that I was teaching for advanced image processing tools. And I found out that QGIS can also do very high level, for example, spectral signature analysis and so on. So I will tell you where I am now, let's say, with the use of these tools. What I'm focusing in this moment from the integrated system of monitoring integrated system of illicit crops in Peru is the all the spatial analysis process. So what we focus in our studies, because it's a research project actually, is the value change in analytics. So all the work we do start with some research questions. Many times they change during the work. Then, of course, there is the phase of data collection that can be data generated by the government or other institution, civil sector, but also generated by us, for example, through field work or image processing. But then there is an important transformation of the data into models, because we work, as I will show later, with a lot of variables, but too much data doesn't help to take decisions or to identify a strategy for, in our case, a fight against drug trafficking and crimes. So we do this important transformation process and apply different kind of analytics. And then we found out very useful to use visualization tools like dashboard, for example, where we can interact with the database and do question, look for answer, observe the behavior of indicators and variables, and so understand it, do a right interpretation of the reality we are analyzing. And then we always finish with the action, let's say with some recommendation or a roadmap for the government to assist decision maker in taking the action based on evidence, so on analytical insights. So as I told you, I started to use QGIS in 2008 when it was definitely not user-friendly and was not so powerful like now. But slowly, I start to use QGIS more and more and more. And in these last few years, I start to use QGIS together with Postgres SQL and PostGIS database, with the help of my colleagues, of course. So it's incredible the power of these tools when you put them together, because you really can start to work with big data. And the analytic process that you can do is very fast and very powerful. So we can manage thousands of data and process them very, very fast. While before I was doing them like with intersection between spatial layers and then union, and then to work on the table of attributes to reach the same result. So it's incredible. I suggest to everybody to explore these tools together with QGIS. And then we use sometimes Power BI, but there are also open source tools like Metabase to do this dashboard analysis of the result. So as I told you, the power of these tools is that you can work and connect this database into the QGIS, from the QGIS. So you can use this interface that you are very friendly, that you are used to use, and work with this very powerful database. So when you manage a large volume of data, we consider the use of these technologies mandatory. Imagine that just when we do, for example, the intersection between coca crops and the eradicated area in Peru, we are talking about 50 million records just in working with one layer, and we work with a lot of layers. So this is great. And in this period, I think everybody works with a lot of data, so this can be very useful. So just to show you a little bit more, we always apply this technology with QGIS like the core tool. In data collection, transformation, and analysis, we start with 100 variables, we create derived variables, and we generate indicators. So then we monitor indicators. And there is all a very hard process of data standardization that is very important also to analyze the quality of the data and the consistency. And then there is the building of this PostGIS database, and also to design the automatization, I think is in English, of the geoprocessing. So all this work is kind of hard, but then the result is incredible because you have a database ready to use for analytics where you can ask many questions and look for answer in an exploratory way at the beginning and in deeper way afterward. So we always use like geographic information, and we are using always more and more grids for our analysis because it helps a lot to synthesize, to put together to represent indicator and analyze indicator generated by the combination of many variables. So here is just an example of when you cross all the layers in this kind of database, then you can analyze the changes, identify a lot of type like new coca crops, permanent coca crops, abandoned, the coca crops that has been eradicated and reseeded, and so on. And then you can analyze the behavior along the time, not only visually, but also with graphic. No, here we want to understand the impact of eradication. So we made a comparison of the behavior of area in cells where eradication was implemented and where not. And we analyzed, for example, the behavior on new crops. So the dynamics was much more active where eradication was operating. And now I want to show you another example of a study, that is a case study that I decided to present today, that where we want to understand the relationship between the environmental crimes and the coca activities. That means not only coca crops production, but also the transformation process. So we were looking for the relationship between these crimes. So with a special focus on environment. So we start with 140 variables. We identify 46 that were relevant for the study. Then starting from these 46 variables, doing intersection, union, and applying also operation on the data, we generated 26 derived variables. For example, I don't know, the forest loss due to new coca crops. And then we created 7 indicators that, let's say, show us the insights of the project. The indicators we built on a grid base. Okay, and so we also analyze on satellite images with a multi-temporal approach. And what we found out is that the 75% of new coca crops between 21 and 22 in this region called Ucayali, that is in the border with Brazil, so hi to the Brazilian speaker, were directly, they were causing direct deforestation. So they were a driver of deforestation. When you analyze the number of forest loss due to a different driver, you can suppose that coca crops are not so relevant because the quantity of hectares is not so big. But when you do the grid analysis, then you find out that there are sectors that here you can see in red, where the main driver of deforestation are coca crops. So this has a lot of implication for the government, of course, because it's an illegal activity. So then we do this analysis. We start to analyze the convergence, the crime confluence. So we build using the grid a crime confluence index, confluence index that is measuring the number of different crimes, but also the intensity. So we found out that these crimes does not a homogeneous behavior in the territory. So with these 2 results, we start to analyze all the territory through a a key analysis that was the land trafficking. So we analyzed the category of the territory on a spatial base. We analyzed the land trafficking in the territory, and we found out that depending of the kind of land trafficking, that can be just invasion of native territory, of governmental territory, of forest concession, or massive titling, that is like an illegal way to have a lot of title in where it's not supposed to be, or doing falsificating certificate. We found out different confluence of different crimes. So this allowed us to identify 3 sectors in this region, and each sector has different behavior based not only on deforestation, but also, as we will see, confluence of crime. And each sector needed a specific strategy of intervention. So this was very useful. So in each sector, we did this kind of characterization. So what is the modality of land trafficking? What is the confluence of environmental crime and the related crime in this sector, and other, let's see, roots present. So each sector has a different behavior that we found out through this kind of analysis. We also found out a new strategy of criminal groups that are financing the deforestation of very huge areas, and so on. Here is also a case study that we presented, where you can see in red the first coca hotspots, then the opening of an illegal road, and then installation of titles or residents started, and so on, growing, and slowly started when the territory was already in a legal way. The purple line identify a native community area. Also from the bottom start the penetration roads for deforestation, and slowly these areas start to degrade, to show degradation of the forest due to selective deforestation. And at the end, in 2022, the laboratory of drug production appears. So this shows how the territory dynamic goes, and how the crime groups start to control territory and the environmental impact associated. All this work has been done with the 18 institutions involved in all the phases of the studies. This was the greatest part, I think, because the results were their own results. And so, just as a conclusion, I think that these spatial analysis techniques and open technology in general can maximize the data as a strategic asset, and can help to build an evidence base for decision making. So it's like they unlocks added value from our data and leads to insights. And QGIS is great because it's not only accessible to everybody, but it's also highly interoperable. So I really like it very much. And these are some study that we did in the last 2 years. There is some story maps, but sorry, made with RGs. and that's all.
Wow, thank you very much for your presentation.
I don't know if it was too long.
No,
maybe
at the right time. I was here watching it. Impressive how yes complex the topic is, and how everything
easy.
no at all. And one thing lead to another. No, it's also interesting to see the correlations.
Yes.
Thank you very much. I will now open the questions for the speakers. Maybe, well, I will start with you, Luisa, since you are here. We have a question. What are the 7 indicators and how were they selected?
Okay, I don't remember all the 7, but one was the quantity of forest loss due directly from coca crops. The other one was the mean size of crops, because the dimension of the coca crops helped us to understand the intervention of criminal groups, because the deforestation of 15 hectares of prime forest is not so cheap. So this means that the criminal groups are present since the beginning, since the invasion of land, basically. So this was too. While you do other question, I check the other presentation and I answer you. Okay.
Yes.
I
Oh, the
remember
question
all of them.
was also one participant asked if you faced any difficulties when you did the project.
Oh, of course, many difficulties, especially on the quality of data, because we went in field. Of course, there are the difficulties of the risk associated to this kind of work when you go in the field. But I think the most critical was the quality of data. I mean, which are the official data? So we were working with the territory categories. That means, I don't know, native communities and permanent production, forest. I mean, all this category of land use, basically. And I mean, each institution have two layers that are not the same. So I mean, was like, oh my God. So we did a very hard work to identify the official one, the more actualized, and we found out a lot of overlap. Was crazy. That was an important highlight also to, okay, we have to work on this, because of course illegal groups use this weakness on the data management to do illegal activities.
That is true. Wow, but interesting that it was more problematic, the data, than the conflicts, no, or the security.
Yeah. We are a United Nations. We check the security before going. And in my team, there are guys that have a lot of experience in that, actually.
Great. Thank you very much for this incredible presentation. We are very happy that you could participate with us
I
today.
think there are there are more questions for Luisa.
Yeah. Okay,
Yes.
give me one more, because we also have questions
yeah.
from the other speakers.
Maybe I can answer them in the chat if you want.
Okay, let's go
yes.
then to the
Okay.
other speakers, and then we can see. I will call now Audrey to
Yeah.
join us. Here you are. Let me just change. So we had some questions, but due to the time, you can also see them on the chat. But one participant asked, can you explain how you calculated the accuracy and what does it mean? But I want to combine it with another question that says the ground control points were concentrated in only one part of the reservoir, which increased bias and caused the accuracy of the classification into question. How did you address this issue?
Okay, thank you, Barbara. For the first question related to the accuracy assessment, I think it's just the calculation of some metrics to try to see how the classification was well done. So first we have a training set for the training data, and we also have a set for the validation. And we compute later what we call the confusion matrix. And in the confusion matrix, we see how well the points have been assigned to the right class, because as I was saying, it was a classification. So we have a lot of metrics like overall accuracy, producers accuracy, users accuracy, kappa, F1 score. So if you could read about it, so it's a lot of things. So as we not have a lot of time. Now for the second question, it's about, you said, okay, yes. So for the ground truth points, What I've shown on the slide, it was just for one reservoir, and it was just to, and I only presented the points that represented water. So it was not all the points that I've shown as I've presented, and you have seen, maybe you have seen, we work on 20 reservoirs, different reservoirs. So I just presented the points that we gathered for the water class, but we have other points that we use for the classification. Not know if
Thank you. Maybe we can go for one more. Considering that the reservoirs have varied shapes and you use point coordinates for ground truth, what kind of buffering approach did you use to account for the irregular shape?
Okay, so we use points as I've presented. We use machine learning algorithm, and we especially use random forest. So what we use as training data was points, and it was to conduct a classification. We didn't use objects like polygons to train our models. So we have points for all the reservoirs, and now we classify for all the dates for which we have quality images. I mean, for Sentinel-2, for instance, we know that we have clouds that could lead to very bad images, but we classify the images for all the dates that are available. So for one reservoir, for instance, we could have 300 dates for which we classify that specific reservoir. So we were able to see now the surface area variation of each reservoir. So we didn't use objects based classification, but we use points to train our models. Thank you.
Thank you for your answers. I hope the participants are happy with your and one second. And now I will call Ricardo to also answer some questions. Thank you. So how does land use and land cover affect digital beehive?
Yeah, so thanks for the questions. And so the idea is that the bees depend on specific land covers. Like we're talking about bees needing vegetation, and within this type of land cover, that's the vegetation. What type of the vegetation it's better for the bees. So that's the kind of a relationship that we make with land uses and improving the production capacity of the bees.
Okay. And are you able to influence or discourage the use of pesticides by individual farmers?
Yeah, so this is one of our ideas because I'll actually linking to another question that I read. The idea is to give this platform to associations so they can operate it themselves, and this would create a kind of autonomous monitoring system for the region. So if the neighbors know that one of the neighbors producing something with pesticides, know that it will be used on this on that day, they can take some measures. Sorry,
Ricardo, I'm sorry to interrupt. You were
no problem.
breaking a bit. Could you please repeat?
Yeah, sure. Sorry. So
Not the whole.
Is it working now? So hi. Is it working?
Hi, hello. Now you're back. Yes, now it's working.
I think it's raining too much here and it's not working. So, but the idea is that the association would be aware if any of the neighbors is using any kind of pesticide and take some measures to it, like the shift the locations, or in a better situation, directly intervene against the use of this. But so the idea is that it gives a tool to the community to organize themselves alone. So it's more like giving tools than yeah than everything. Yeah. And we didn't put in practice yet, so I cannot say if it worked or not. It will work or not.
Yes, hopefully it will. And we invite you again so you can tell us if it worked. Thank you very much. Maybe we can we still have some time. We can have one more question for Luisa, if she's here.
Yes, of course. Maybe there is just one question that I didn't answer, that it was the Maswandle, very hard name.
Yeah, exactly. This one I was also thinking was interesting.
Yes, I mean, depends on, I mean, there are many cases, but in Peru, at least in Ucayali, in this forest region, there can be like a tenure, official tenure of the land.
I'm
But
sorry to interrupt. Could I read the question? So
okay, of course, I'm sorry. Yeah.
No problem. So the question was, what kind of tenure rights do citizens have? Is the land owned by individuals or the government? I think there is too much encroachment into the forest area. What are the land use seem to be encroaching into the forest side of the coca farming?
Okay, I tried to be fast. So there is the possibility to have a tenure of a land, but just in specific area. So all the territory is divided in categories. So if is a productive primary forest, cannot be a possession certificate. So when you find it, is because there is corruption beside that. So we found case of official tenure documentation and case of falsification with corruption. No? And then there are areas that are owned by the government. So where did we find more criticism talking about the invasion of coca crops? In the forest concessions that are government territory, that are like given to someone to protect. Okay, but in generally, we're not the owner of the concession who was cultivating coca. We're invasor of this, no? And yes, there is a lot of invasion of the forest, especially since 2020. This is a new dynamic, very tragic, because they also go into native territories, and they are killing many also environmental defenders and corrupting others, unluckily.
Unfortunately. I'm just checking if there is more questions. Yeah, Ana Cecilia was commenting that in 2020, during the COVID pandemic,
Yes.
also it started a lot.
Mm-mm.
Thank you very much. I think we are approaching to our end. If there is one more question for any of the of
There
our
is a
speakers.
hand, I think.
Yes, Robert, would you like to say something? Maybe no.
Dr. Robert, the mic is open.
Hello? We cannot hear you. Unfortunately, no. You're.
Maybe you can write your question. It would be better, maybe. If you can write it in the chat, Dr. Robert. Yes, because we cannot hear you. It's absolutely muted. Okay.
In the meanwhile, I would like to thank you all again and remind that this webinar is being recorded. We will share it in our social media. We will upload it to the YouTube and share it with all of you. And let's wait for some minutes. People were thanking all the presenters.
Here is a question from the QGIS presenter.
May I know the type of models he used in the study? For Audrey,
I can send, okay. I can, maybe it's easier that I send the study. You can share the study with the who wants it, maybe, because I mean, it's not so easy to explain it now. So basically, are spatial analysis models, but the core model is in the database. So it's very complex, the answer, actually.
definitely. If you can share it with us, it would be very interesting.
Maybe we can have a picture, or is
No,
this?
because it's a webinar.
It's a webinar. Okay.
Have a cameras. But thank you very much. I will just share quickly my screen to say thank you all. It's not appearing. But yes, thank you for being here, and hopefully we see each other very soon.
Bye-bye.
Bye-bye.
Bye-bye. Thank you.
Bye.
Thank you so much.
Thank you so much. Bye-bye.
Bye-bye. Thank you.
Mm.